Dobrý deň, večer. Ja sa vám musím ospravedlniť, ja budem rozprávať po anglicky. Lebo o tom, o čom budem rozprávať, ja neviem rozprávať po anglicky, lebo nemám tú potrebnú terminológiu na túto tému a ja som nepracovala v tejto oblasti na Slovensku, takže to by bolo veľmi koktavé a by sa to veľmi zle počúvalo. Tak sa ešte raz ospravedlňujem, že takto hriech robím na rodnej hrude, Slovák Slovákom, po anglicky. Inak toto je tretia prednáška. Ja som na turné. Prvá bola v Prahe. Najprv som bola na Google Developer Day v útorok. V stredu som prednášala v Prahe a vo štvrtok včera som bola v Krakove. A dnes som posledná prednáška na Slovensku. Sme skončili doma. Volám sa Peťka Kryžiková. Cross. No, písať neviem. Tu je len také krátke bio. Ak chcete vizitku, tak si potom príďte zobrať. Pochádzam zo Žiliny. Máme tu Žilinčanov? Jej. Študovala som na Žilinskej univerzite 4 roky z 5. Nedoštudovaná som prestúpila na Santa Clara University v Santa Clara, Kalifornia, kde som doštudovala matematiku a informatiku, teda computer science, čiže informatiku. A Google, nebola som prvým zamestnancom, ale bola som prvým inžinierom z bývalého Československa. Takže sme boli prví, nie Češi. A v roku 2005, bože, to bolo dávno, som začala pracovať ako softwarový inžinier vo vyhľadávaní. Dobre mi to ide zatiaľ po slovensky, ale budem musieť prehodiť za chvíľku. A od roku 2008 pracujem v tíme Gmail Frontend, čiže predok Gmail. A v Googleplexe sa dosť dobre vyznám, takže keď prídete, tak mi treba poslať e-mail a môžem s vami prejsť okolo Googleplexu a ukázať vám Googleplex. A ešte mám aj psíčka, ktorého si do práce nosím. OK. Tento slajd vyzerá na prvý pohľad tak, že nepatrí do tejto prezentácie, lebo ja som vám prišla rozprávať o vývoji softvéru Google, ale stojím tu pred vami a ukazujem vám našu misiu. OK, teraz naozaj idem po anglicky. Every Googler knows this sentence. This is something that if you wake me up at 4 a.m., I'll tell you this sentence. This is what Google's trying to do, to organize the world's information and make it universally accessible and useful. And the reason why I'm bringing it up is because everything we do, even what I'm going to talk about later, directly relates to this mission. It tries to accomplish this mission. So now that you know what Google's trying to do, I'm going to tell you what I'm here to talk about. This is the third talk, and I was told that the first half of the talk is going to be really easy to follow, and the second half is going to be there's going to be a lot more information in the second half. So please take it easy for now, but 30 minutes from now, pay attention. There's going to be a lot of useful information. First, I'm going to show you what it looks like at Google, what the teams look like, what roles people have, what does the management structure look like. I'm going to show you a couple of pictures of the work environment of the office so you can see how we sit. And then I'm going to start talking about the software development methodologies that are used in the software industry. There's like 3 of them. It's not going to take too long. But then the second half of the talk is going to be about what Google does specifically and how we develop software to make sure that we only focus on what needs to be done and we don't waste our energy and resources on features we don't need. So let's start talking about the teams and roles. If you have any questions, just lift your arm and I'm just going to answer right away, okay? And I have some prizes, so whoever is most curious or active or participates, I have gifts for you. I have a frisbee, I can just throw it at you, right? And I have some pins and stickers and tattoos, if you want to be tattooed, and pins. I apologize for this slide. It's quite complicated. It's the busiest slide in this presentation. The other slides are going to be a lot easier. So I just wanted to put it in one place. It shows a structure in a typical engineering team. I don't know much about what Marek and Juraj do because they work in a different organization within Google. But I'm only going to talk about how it how it works in the engineering group. Every product or every effort, such as social or search, would have a vice president of engineering. You're probably familiar with those for Google+. Vic, do you know Vic? Yeah, he's the vice president of engineering. And then these people then manage multiple engineering directors. And an engineering director would be managing one team, one product. So for example, Gmail has one engineering director. This person thinks big picture, deals with the real big picture decisions, whether to create product, whether to not create product, how many tens of engineers they need, and things like that. But they don't work on the actual development of the product. The engineers do. So you would have an engineering director who would be managing multiple managers. Now, engineering manager is a person who used to be a software engineer or some kind of engineer. Everyone in the structure actually used to be an engineer. We don't just hire people who just study management. It's really important that you understand engineering and you understand how stuff is built using software. So this engineering manager is a person who has 10, 15 years of engineering experience and has great leadership skills, so this person eventually grew into the role of a manager. The product manager, PM, is a person who is responsible for deciding what the customer needs and translating that into specific features and requirements for the product. So product manager is really, to me as an engineer, it's my customer. I'm trying to build what product manager asks me to build. SWE, software engineer, developer, right, is probably what you're most familiar with. It's a programmer. But programmer just programs. Software engineer is responsible for programming, but as also creating software systems and architecting the system itself and testing it and maintaining it. But programming is about 50% of the work. The software engineer slash TL is a person, I'm actually a TL, that's my role right there, is a person who is a software engineer, who writes software, but in addition to that, they lead a small team of people. It tends to be the size of a family, 3 to 5 people, 6 maybe. And it's not a manager, it's just a developer like anyone else. But this person should be senior enough to be able to advise other people on the team and to be able to interface with other teams. Because if other team at Google wants to do some kind of API or wants to use our software, they're not going to bother everyone on my team. They would contact me and I would meet with them. So what I'm really doing, I have more meetings than the rest of the people on my team. And TLs are the people who tend to talk to PMs and to engineering managers most often. SCT is, again, a software engineer, but the person who creates test frameworks. Frameworks that allow you to test end-to-end, or they are allowing you to create automation tests. Things that are usually custom designed for a specific product. And TE is a test engineer. This person just writes test cases. This person uses the testing framework to create the actual tests, to test the framework, to test the product. This is just an example of the hierarchy. It's like a tree, but the point is that you can see there's mostly SWEs, and they're all at the same level. Google has a very flat structure, and engineering managers tend to manage many people. And very few you see manager that manages manager that manages manager. You would usually have engineering manager and then engineers, and that's where it ends. So I mentioned in the last slide that each team is the size of the family. So for example, if this engineering manager manages Gmail frontend, this would be my team. Let's say we have 4 or 5 or 6 teams on the front end, and each of them would have 3 to 5 people. The intern is optional, but every team has one tech lead. This is what it looks like. It's circa 2008. I'm back in the last century. Anyways, you can see that when you join, you get 2 monitors. You either get 2 24-inch monitors or one 30-inch monitor. And some people, like this guy, the guy who's standing, his name is Greg. He managed to steal additional 2 monitors somewhere. He's got 4. The way we structure the desks is we don't sit in the offices. I don't know how it works in the sales organization. Do you guys have offices or open space?
We have combination.
Combination, okay. So in engineering, it's extremely important that you are completely surrounded by people that you work with. We don't have 1 person per office or 1 person per cubicle. In fact, this is not even a cubicle. It's like a giant area that's surrounded by a cubicle wall. And a team would be a cluster of desks. Some people like to have privacy. Sorry, maybe Google's not the right place for you. If you want not to be bothered by other people, put headphones on you and listen to music. That usually means, please don't bother me. But it's really fun when you're surrounded by people. It's like working, like doing your homeworks in the dorm room, right? You have people around you. You're trying to focus on the homework, and you can ask for advice. You can work together with your roommates, right? So it's very much like a college experience. I had to plug it in. This is my shameless plug, my dog, Fluffy. She's chilling on a beanbag. There's dogs allowed, so you can bring dogs, but you cannot bring other animals, unfortunately. Some buildings have their own rules. I'm pretty sure you guys cannot bring dogs here in Bratislava, can you?
I don't know, actually. I don't know.
Try it.
We haven't tried it. We haven't tried tiger either.
Tiger. All right, and this is where we sit right now. We moved to a much nicer building. This is the same building where Google Store is located, so I brought a bunch of goodies for you from the store. The thing to point out here is, wow, it's so dark. Okay, notice the white walls.
A quick one. I don't know how many of you will go to Mountain View, but definitely check it out. But if you even go to New York, it's an amazing experience even for me. I have seen quite a few offices, especially being a consultant. I've seen a lot around the world, but I've never seen anything close to what Google is in New York. It's there are Slovak guys. I was not a Google guy then I checked it out, and there was a Slovak guy, Pavel, who took me around. If you do a bit of research, thinking, I'm sure you can find him. And he will be surely.
Pavel Juhoš?
Huh?
Pavel Juhoš?
Yes.
I know him.
He's a very nice guy. He actually went directly from Latvia, I think, to the US.
He worked in China for a while.
Oh, sorry, you're right. Yeah, he worked in China for a bit, and then he went to the US, and he will be happy to take you around.
Yeah, we have a slide in this building. It's a plastic slide, so by the time you get to the bottom, your hair is all like electric. But there is another metal slide in the building right next to us. People like the slides. Anyways, I want to point out the balloon. The balloon at the desk means that a Googler sits there, new Googler, a new employee sits there. And also, I don't know if you can see it in the picture, but there is a dog gate around. I guess someone has a dog in that area. All right, let's actually talk about something important. What are we doing here? What's the whole point of sitting there and working? What are we trying to achieve? And now this is the big question, and deserves the biggest prize. What are we doing in the, sitting behind those desks? No? Come on. Did you pay attention to the first part of the slide? Organize world's information and making it universally accessible and useful. Just come and get it. Come and get it. All right. Oh, there's a sleeve for it. Thanks. I hope I woke you up. There it is. How are we doing it? You can just come get some pen or something if you have the answer. How would you make information useful and accessible? Duh, come on, think. Wake up. Huh?
Organizing the
How about, okay, I'll put you on a spot, Rasto. You should know this.
by organizing it, I think.
Nah. By writing software, duh, we're a software company, right? While making a lot of money. All right, so this is what a typical software development stages would look like. I think at most companies, I hope. You start with an idea. Most of them will never get implemented. But then the PM, the project manager, would translate them into features, into specific features that need to be implemented. And then the PM and the tech lead would be planning it. And they would decide what gets done first, what gets done second, what never gets done, what gets done next year, and so on. Then software engineers will be working on these features, writing software. We also write our own unit tests. So we don't have testers for that. Developers write their own unit tests. And then once it's written and the tests are passing, you would send it for code review. We always make sure that at least 2 sets of eyes see every single 2 pairs of eyes see every single change that goes into production. So 2 people need to check every code because we don't want anyone to checking some malicious code or just write something poorly or skip tests or things like that. And if the code reviewer agrees and is happy with the new change, with the new sets of, with the new 200 lines of code, and is happy with the amount of tests for it, then this person would approve this change, and the person who wrote the change would then submit it into the code repository. Once it's submitted, it will take a couple of days until release engineering, that's another role I didn't talk about. A release engineer would take the snapshot of the code base, the snapshot that passes all the tests. They call it a healthy or green change. And then they would build a binary, let's say a Gmail front-end binary, Gmail server. And they would push it onto a couple of servers or a few dozen of servers in the case of Google. Go ahead, question?
Okay, so all your tests are human-driven, so no machine learning, no...
Oh, there's all kind. Well, there's many types of tests.
Okay, not necessarily, right? So you also make automatic tests?
Yes, there's end-to-end tests, automation tests, there's unit tests. I don't know. There's a separate testing structure and testing engineers that work on many other kinds of tests. All right, so once it's pushed into, let's say, 20 servers, people in Hyderabad in India wake up and the binary is already running and they can test it. Now, when I'm saying testing, this is actual manual testing. It already has been tested using automated tests and using unit tests. So unit tests, they usually make sure that the functionality of your functions or methods is correct. But then the automation test, they would test like the end-to-end behavior. And the testers, the manual testers in India, the QA, they would behave as users. They would be clicking on the UI, make sure everything looks good, nothing is malformed or not working. And then we wake up, we come to work, and we already have like 3 issues that they reported. And then we fix it and so forth. So once it's fixed, then it's pushed to Canary. Canary is a larger set of machines. You would have, I don't know, 100 or maybe 1,000 of machines. And Canary, every team defines Canary differently, but it might be, let's say, 1% of all users or 3% of all users. So you might be actually running your Gmail on Canary without knowing it. But what we do, we are watching the stats for 2 days, see the latency, see how quickly Gmail loads for you, see if we see any exceptions in the logs, things like that. And if it looks good, then it gets approved for the actual production push. It gets pushed to 100% of users. And then, yeah, we're live. So this is, I guess, what every company goes through to get from idea to a product that's usable and useful to users. And this is what we're trying to do. Because, oh, I just saw a guy and he did.
It's like black test on gray background.
Oh, really? You don't see well?
It's not a smart idea.
Black test on what? On Blueback?
No, the background of the picture of the team is grayish.
Oh, yeah. Actually, it's light blue and it looks perfect on my screen, but something's happened. I don't know. You can come here if you want to see it. But it's the same stuff I was talking about in the previous slide, so it's just shrunk. The point is, we want to achieve this in a much shorter time. So how would you do that? We want to develop fast. You can't just make people like, hey, work twice as fast. No. Or you add more people. That's not a good idea, right? Because the more people you add, the slower the team gets. Basically, as any company, Google wants to maximize the return on investment on development time. So you add resources or reduce waste. What's the right answer? What should you do? Reduce waste. Come and get something. There's only 3 pens left. It's going to be first come, first serve, so you might not get it at the end. So we are not trying to lose money, okay? Here's an example that in America itself, $60 billion, which is miliarda dollars, I have it there because it wasn't clear, gets wasted every year. And this does not include projects that are delivered late or projects that go over budget, which probably most of them do. All right, we don't want that. Here is another list, don't even bother reading it. I'm just going to read one line from it. In 1994, the state of California, DMV, that's Department of Motor Vehicles, a place where you would get your car registrations, driver's license, and passports. They wasted $44 million on a system that was canceled. I guess maybe it didn't handle the load or something. So every year, lots of companies are wasting lots of money. We don't want that. And now I'm switching gears. I'm going to talk about the actual software development methodologies, how different companies do this. I'm going to talk about these 3 different kinds of methodologies. You probably have seen at least 2 of them. This is the old school one, the one that's used in car manufacturing or building, actual buildings, construction. You can't change things, physical, tangible things after they are built, right? You're not going to build a car and then say, ooh, it should be actually 5 centimeters taller, right? You can't do this. So it only makes sense that you start with the requirements. Can you see what it says? Requirements, design, implementation, verification, maintenance. You start with requirements up front, and they are set in stone. You cannot change them. You have to follow them until the end. Obviously, this takes a long time, and at the end, you might end up with the product that the customer doesn't really want. So this is really scary, and no one should be using it. But it was the first thing that people started doing in software development because that's all they knew from development of tangible items. And then someone had an idea that what if we do this, but we define requirements every time we design, like at the beginning of designing a prototype. So you would design like 5 prototypes. The first one, you would get a set of requirements, go into like 6 or 9 months phase of developing it, and after 9 months you show it to the customer. Customer gives you feedback, and then you go again to the same cycle. It's like multiple waterfalls after one another. And you can only change the requirements every 6 to 9 months. It is a little better, right? Because you can do what customer wants eventually, but it still takes a long time, and it might be a large number of prototypes. Not a good idea for us. And now, the word that shall not be mentioned, the word agile. Some people are afraid of the word, but I'm going to mention it anyways. Agile or lean development is a methodology that's, let me compare it to some real world example. Imagine you're driving a boat. You probably don't have boats, right? But imagine you are driving a boat. You're playing computer game driving a boat. And you have an island in front of you. If you are allowed to steer the wheel every hour, right, to point it to the island, you will go like zigzag. It will take you a long time to get to the island. You'll get there. So that was probably the spiral model, right? Agile allows you to adjust your wheel and keep pointing to the island constantly. So that's what we want to do. What's key here is that developers constantly collaborate with customers or project managers in our case. So the customer doesn't come back after the first demo is done, but the customer can tell you that you're doing something wrong if you're like halfway through coding it. You are very flexible. You can respond to change very quickly. You work in 1 to 2 week iterations, no 6 months. Our team is working in 1 week iterations, but I know teams at Google that do 2 weeks. And you are working on features instead of prototypes. So it's per feature. You release very quickly because every time you're done with a feature, you can build a binary and push it, and you can see it live and have a customer feedback on it. And I already showed you pictures of the open office space where you collaborate with your coworkers. You are constantly talking about what you're working on. These are the 3 most known flavors of Agile. You familiar with extreme programming? Are you? It's probably most well known for pairing. There is a word for it. It's called promiscuous pairing. You're supposed to be pairing promiscuously, always with someone else. Every day you would be coding side by side next to a different engineer on your team, and you would rotate. It's great because you would learn a lot from the other person, and if you have two brains together, they generate a lot more elegant solutions than just one person. Scrum, I'm not going to talk about it much because I honestly don't know much about Scrum. It's a project management methodology. So project managers use this methodology to manage Agile teams. And Kanban one is an interesting one. Do we have a Japanese person here? Or someone who speaks Japanese? No? Okay. So Kanban means a board or sign or a whiteboard. And here's an example of Kanban card, Kanban board for Toyota manufacturer. What they do, they have one of these cards on every single part that's in their logistics system. And anywhere in the logistics system, you see a part like a door, car door. It would have this thing attached to it. And you would see where it was, what stages it's in right now, and where it's supposed to be next, and by when. So it's like tracking every single little piece in the system. It's attached to the specific object. We're doing something similar, except we don't attach it to stuff. We attach it to tasks. Each task will have its own card, but I'll get to this later. So what do you think Google does from what I just explained? Do we use waterfall? Do we use spiral? No? Agile? And in Agile, what do we do? Yeah, a little bit of everything. We actually create our own, but mostly Agile. All right, if you go to this thing called google.com or google.sk, you type in 10 things, you're going to get results. And the first result is a list of things that Google found to be true. And the first item on the list is a statement that says, if you focus on the user, everything else will follow. We actually happen to do this even in our day-to-day job. We start with what the user wants. We call this a user story. So imagine that a user story would be, for example, here's one example. A bankomat user, ATM user, wants to be able to see their balance when they use bankomat. That's a story, right? Because it's something that the customer, it's like a feature from the point of view of the customer. A story is something that must be clearly defined. It must be clear when it's done. They call this an acceptance test. If it's not clear, then it's a poorly written story. And this is in the world of project management and in the world of customers and users. Tasks is the world of engineers. So what we need to do, we need to translate it from the story into the actual task. You might translate one story into 5 tasks. I mean, a feature like that might require multiple different things that you have to do. So a task is really just a story broken down. I'm going to give you more examples in the next slide. Maybe they will make it clear. Are you guys all engineering students? Software, hardware, electrical? Software, okay, you're going to understand this. So, because I gave a talk to non-engineers and I had to go into a lot of detail. So in this example, someone is a software engineer working for a bank, and their project manager comes in and says, this is the story, do it. And bankomat user wants to see their balance. So you want to break it into tasks. Each task shouldn't take more than 2 days. Okay, they need to be small. The first thing you want to do is define some kind of API so that the machine, the bankomat, the ATM can communicate with some kind of server that's in a data center or somewhere in the bank, right? Once you define that, you might want to go ahead and make change to the backend, to the server, so that the server knows how to go to database and wherever, get the balance and return it, and perhaps even authenticate you, right? And a third task would be to have a front-end engineer and a UI designer design some nice UI for it with a button that the user would touch, right? And it would show you beautifully formatted balance. And obviously that thing would talk to the API and talk to the server. So this is just an example of how you would break down a story into tasks. You can actually apply this, everything that I'm teaching or explaining today, to any kind of business, not just software. You can do this as long as you have at least 2 people that you work with in the team. If you have a team of 5 and you have a lot of things you have to do, you can create your own tasks, and they can be something else than writing software, and this will work. All right, now we're going to talk about the different states. Like, like the Kanban card I showed you, the Toyota card, how the part travels through the system in logistics system, and it's just like it goes through, I don't know, it's being pressed into, I don't know, how do you make a car door, right? You start with the metal and then cut out the door. Okay, help me out, please. And then someone needs to paint it at some point, install windows in it, things like that, right? So it goes through these states. A task also goes through the states, and they obviously make sense. You start with an icebox. Icebox is just a list of stuff. It's anything, feature requests or tasks. They can be already broken down, stories or tasks. Anything that anyone wants from you. Whether it's something like, go give a talk at the university. This is actually a task that I'm doing right now. Or whether it's like, go get a passport. Or whether it's, implement this feature. Anything. It doesn't mean you actually will do it. You don't want to start working on everything that people ask you to do, because then you will never end up focusing on what you were supposed to be doing. You just accept every request, say yes to everyone, put it into Icebox. It's just a list. It's a spreadsheet, whatever, a list. It's not even ordered. It's just a pile of stuff someone wants you to work on. But then the project manager, the person who wants to get this product out, will pick the items from the Icebox and then put them in a separate list, only a small number of them, in a separate list, which they call a backlog or work list. And this one's ordered. This means stuff is going to get done in this order. We are committing to working on these tasks. So these are the most important one is the backlog. It needs to be prioritized, and it needs to be, this is what gets done. Everything else won't. So it's very important what's in the backlog and where in the backlog. Do you see this? Can we turn off the lights? The difference between Icebox and backlog. I'm very visual. I'm a photographer, and this is probably very useful to you. On the left, Icebox, pile of crap. On the right, it's ordered. Hopefully it's a smaller pile. It's hard to tell. And it's the way, it's ordered. All right, can we turn the lights on? Thank you. So once you start working on it, it changes its state to, it's being worked on, right? That's the upper stage. It just means that someone is coding it right now. Once it's done, it changes its state to done. These are the most important ones. And now we need to turn the lights off again. I'm sorry. Here's a real example of a whiteboard. This is the Kanban board with Kanban cards. And let me tell you, it's probably not clear from here. I'll read what's on it. On the left, you see swim lanes in the pool. We call these things swim lanes because they look like swim lanes. And each swim lane contains tasks that have the same state. So everything in the left column is backlog. That's no one's working on it yet, but we are committed to work on it in that order. So if you are an engineer and you're ready to pick up your next task, you would just take the top one, the top task on the upper left corner, and start working on it. The next column is the one that says working on. Notice there's a picture of people's face next to every task in this column. Do you see that? Are you sleeping? Should we turn the lights on back or? Okay, so there's a bunch of pictures on the very top, very, very top. If you're an engineer, you would have like 5 pictures there. And then when you pick a task from the left, you put it in the second column and put your picture there, which means you're telling everyone, hey, I'm working on this. My face is on the task, don't take it, I took it, it's my task, I'm working on it. And they have additional stuff. They have in review, I guess they have a separate bucket for in review. Then there's another bucket, another swim lane for checked in, which means it's already checked in into code repository, in QA. So you can create your own. Every team defines their own states, depending on what you need and what matters. Here's just a list. We can turn the lights on. This is a list of the same swim lanes from the previous slide. They are different than what our team does. This is actually a different team. Picture of a different team at Google. All right, I'm going to wake you up now. Do you remember anything from the last 3 slides? Please. Please. So what is the state, the first state that you, the icebox. Then the second, backlog. And what's the most important thing about backlog? It's ordered and it should be small because that's what you are going to work on. The next task, next state, working on, and the next one, done. And then maybe someone else, maybe the testing team, they will have their own stuff. And maybe the release engineering, the people who are actually releasing it to production, they might have their own whiteboard with their own states. So how do these tasks ended up on the whiteboard? By the way, you don't have to use the whiteboard. You can use a software for this. I have a coworker that's in Seattle, and so our team is using this software called Pivotal Tracker for this. It works. It's just, on the screen, swim lanes. There's many different kinds of softwares you can use for this. So how do they end up there? The product manager and the tech lead would put them on the very left column. And then the developers will be moving them to the right. Here's an example of a worst case scenario calendar. Okay? Some people complain they have meetings every day and they don't have time to program because they have all these meetings they have to go to. If you're working on an agile team, you should really only have 1 meeting a week. Ignore the stand-up. You should not have stand-ups, at least if you are on my team. Some teams do that. I'll tell you why we don't do that. And you only should have the planning meeting and maybe retrospective every now and then. I'm going to talk to you about it later, but the goal is that the tech lead and the PM will take the hit. They will be at all the meetings they have to be at, but the developers, people who are just software engineers, they only go to a meeting once a week, and I'm going to tell you what this meeting is about. This is the meeting. We call it planning meeting. Some people take an hour. Our team takes 15, 20 minutes because we improved our process, that we brought it down to only 15 minutes. And I'll tell you how we did it. All you do at this meeting, when you show up at this meeting, the backlog is already populated. It has stuff because PM and tech lead put the tasks and user stories there. What we do, we look at the top of the backlog because you can only do like 10 tasks a week, depending on how many people you have on a team. So if we do 10 tasks a week, we will look at the top 12 tasks because that's probably what we will end up doing next week. And we only look at that and plan it and decide that we are going to work on this in the next week until next meeting because we have these weekly cycles. Every week we look at the backlog. And what's in the backlog? What types of things? Stories and tasks. Well, and engineers, they don't work on stories. They only work on tasks, right? So what we do, if we see a story in the top 10 list in the backlog, we just break it down into tasks. We will create like 2 or 3 tasks for it. And then we estimate these tasks. I'm going to talk about it in the next slide. That's the fun part. We estimate the tasks, and that's it. We go back to our desks and continue coding. I'm mentioning it for the 3rd time or 4th time. Backlog must be ordered because we don't want to look at the whole thing. We only look at the top.
Who does it? The product manager?
It's the product manager because the product manager is then committing to deadlines and to customers. And estimate as you go, it means that we are not estimating the whole backlog, only the top of it, the one that's like 1 week worth of work. Because product manager might change her mind later and then take stuff out of the backlog. And if we estimated it, we just wasted our time on it. And the way we estimate, we don't estimate in terms of days or hours, because people suck at estimating time. If you ask an engineer, how long is this going to take? They say, 2 hours. Next day, they're still working on it. Oh, there was a bug, and I didn't expect this, and that thing broke, and the build was broken, and it didn't compile, and we had power outage, and God knows what. Anything can happen. If you ask someone how long a bigger task is going to take, they will tell you 2 weeks. It's going to be 4 months, maybe. The bigger the tasks get, the worse people get at estimating. But it turns out, if you can compare it to a different task, you are a lot better. So I show you task A. This is a task. This is a small task. This is 1 point. Is this task as big as this one? Yes? Okay, it's also 1 point. And so when you start doing Agile, you start with 2 example tasks. A 1 point task and a 5 point task or 3 point task. And you base everything on that. You kind of compare it. And after a month, you get really good at estimating. And so let me tell you about how we actually do the estimating itself. I forgot my cards. Okay. Imagine I have cards like this. It starts with question mark, and then we only use 0, 1, 2, 3, 5. We don't go bigger than that. They call this a planning poker. And it's not as fun as poker, I must tell you. But it's still fun in a way, because it's like a ritual. And you are at around a table in a small meeting room. Whoever is facilitating the meeting, like a tech lead usually, would read a task from the backlog and then look at everyone and say 1, 2, 3, and everyone lifts their fingers, we use fingers, or cards with the number. Then you look around, 2, 2, 2, 1, cool, it's going to be 2. And just mark it as 2. Next task, you just read the task, everyone votes, 1, 1, 1, 1, 0, cool, it's going to be 1. If you happen to have disagreement, if you have 1, 2, 2, 5, you're like, uh-oh, what does that mean? What would that mean if people disagree? Everyone thinks that the task is about something else. Someone thinks it's easy, someone thinks it's hard. So it really means that it needs to be clarified. What is this task about? We are not going into any kind of discussion because that will take time. We want to be efficient and lean. All we do is we look at the person with the highest number, the person with 5. The facilitator would look at that person, and then the person would say, to do this task, I have to make a database change, and then my SQL schema change, and I have to wait for that team to finish their feature so I can use it, blah, blah, blah. They would explain like something complicated, right? Then you look at the person who was voting 1, and the person would say, it's a one-liner, right? It's a 1 line of change in this file. And you'd be like, oh, really? It's that easy? Okay. And so we revote. And all of a sudden, it's 1, 1, 1, 1, 1. Okay, 1. Next. The point is, we don't need to all have the same number, but we need to have majority. And if someone has like 2, 2, 2, 2, 3, it's okay, it's 2. Even if it ends up being 3, it averages out. It's good enough. One thing that's interesting about this ritual, it exposes, it shows the differences between people. And it shows you who is the pessimist, who is the optimist. And after a few weeks, people calibrate themselves. They all start voting about on the same level. So it doesn't matter if you are pessimist or optimist, you end up calibrating. You end up being on the same frequency as everyone else. It's really good. You end up voting almost the same numbers very soon. And it also shows you who understands different components and who doesn't. It's not like, we don't want to point finger at people who don't understand, but at least they're aware, I didn't understand this task. I need to learn more about that. This guy or this girl knows most about it. I need to talk to her or work with her more to learn it. So it's really useful for people themselves to just learn about their own skills and abilities. The meeting's over in 15, 20 minutes. 10 tasks have points next to them. By the way, these points are useful to PM. The project manager likes to know how much stuff a team can do in a week or in a month. Because you can take like a moving average, 3-week moving average, and you know that this team can do 20 points a week. And if the PM comes to you and they say, well, how about you do this by the end of the quarter? You look, you estimate, you say, it's 100 points. I can do 20 points, our team can do 20 points per week. If we put this on the top of the backlog and don't work on anything else, just this, it's going to be 5 weeks. And it's extremely accurate. If you didn't do Agile, if the PM comes to you and asks you how long it's going to take you, you say 5 days, right? It might be 5 weeks. So it's really useful for the PM as well as for us.
How do you handle bugs? I mean,
okay.
Back to the product backlog? Or?
Yeah, you create a bug, you have a bug, you create a red card, you put it as a task. It's just red, different colors, so you know that, oh, it should be on top.
But you are handling them in the current sprint, or you wait?
If it's so important, you put it there, otherwise you put it in the next iteration. Bugs can go in, they get priority over everything that's in the backlog, if it's important.
Who recognize how important?
Who recognizes? Well, people usually know what the bug means and how it's going to affect things. If you are not sure, you can ask PM if they want it fixed right away or if it's okay. If it only affects like 1 promille of users, maybe it's like a lower priority of bug. So one question from the previous slide: why do we estimate? Why?
Because you do the work.
No, but why would we bother adding points to tasks? That takes time to estimate, right? 15 minutes a week. That's like 6 people, 15 minutes, that's 1.5 hours of developer time wasted, right? But it still allows you to focus on what really matters and know what you're working on and not end up working on things that you didn't understand and then 4 weeks later someone tells you that it's supposed to be something else. So what we really do here during estimation, we clarify requirements. It's completely clear what this task is about. We're not going to waste time doing something else. So when the meeting is over, we start working. You take stuff from the top of the backlog, work on it, move it 1 column to the right. What time is it, by the way? How are you doing on time? I just want to know what time it is. Okay. So I'm almost done. There's like 2 more slides, so please bear with me. It's good to work on as few tasks as possible. Keep the tasks small. They should not be bigger than 5 points. And when I say 5 points, I mean the task should be somewhere between 1 hour and 2 days worth of work. If it gets bigger, just break it down into more smaller tasks. Okay? Don't ever accept a task that takes 4 weeks to do. Always break it down. And complete transparency. If you have picture next to every story that's being worked on, you know who's working on what. You don't need to ask people for the status meeting. You don't have any status meetings, nothing. You just look at the whiteboard and you see, oh, this person is working on 5 things, wow. Oh, this person is done with everything, so she will take the next step. You know exactly who's doing what. So it's very useful for managers especially and for PMs. This I don't recommend, but I put it here because lots of people do that. People who do Agile often have stand-ups. What you do, you stand for 15 minutes, you hold a stick or some token, and you say, everyone on the team says, this is what I've done yesterday, this is what I'm doing right now, and I'm blocked on that. And you give the stick to someone else. And the reason why you're standing, you don't want the meeting to be too long, and people don't like to stand, so it just forces everyone to like get it out and just end the meeting. But again, if you have it 15 minutes every day times 6 people, 1.5 hours wasted every day. Why do you need to stand up if you have a whiteboard? If you want to see who is working on what, just look at the whiteboard and you see whose pictures is next to each card. But some teams prefer that. Yeah. last slide of the presentation. I still have lots of stuff, so I should somehow engage you here. Retrospective, this is very important. It doesn't happen very often. Some people do it, short meeting a week, or our team does it like once a quarter, but you should have it like once a month. You meet with your team. Okay, by the way, and none of these meetings are attended by managers. It's always just the 5 people, or 4 people, the engineers and their tech lead. Management is not involved here. Manager only meets with tech lead in separate meetings. So this retrospective, you get 3 papers or little cards. Everyone gets 3 cards and a pen. On the first card, they write 2 or 3 things that they think are really good on this team. Like, oh yeah, we have short meetings, I love that. Oh, I have really responsive code reviewers, and I like this, okay? In the next paper, you write what you don't like. This person takes 4 days to respond to my code review, or anything that you don't like about the process. And in the third list, you actually suggest what we need to improve so we are even more agile and more lean and faster and happier on the team. And then you all just read through them and decide how you can improve. And thanks to this retrospective, our team was able to reduce the planning meeting from 1.5 hours to 15 to 20 minutes a week. Now, you'll be surprised, but everything that I just told you, I really don't want you to do, because every team defines their own rules. You can't follow some other team's rules. You can start doing something similar that I just explained in the presentation, but few months down the road, your team is going to be making tweaks and changes to the process, and you will find your own way to work. So even at Google, every team is doing Agile differently, and this is just how our team does this. Now we have some space for questions and answers. Whoever asks will get a sticker or something. I want to get rid of it because I was bringing it all the way from California. I don't want to bring it back. Go ahead.
How do you review code?
How what?
How do you review code?
How do we do code reviews?
Do you call somebody?
No, so we have lots of internal tools and applications and systems, and we have an application for this. In fact, we have 3 different applications we can pick from. There's always an application that's like deprecated, and there's another one that's not just ready. So it's like that in the world. And so we pick one of the applications that we like to use, and in there, we would fill out who we are sending it to. It's like writing an email, who it goes to. Then you write a short paragraph about what you're trying to do here, because sometimes it's not clear just by looking at the code. It should be, but you just say, this is what I'm doing. It's part of a larger goal, and please review it ASAP or something. You send it to one person, or you can CC more people. And they are able to use this tool to look at the code before and after, side by side. And it highlights the lines that are added and the lines that are removed. And they're able to like double click and type in comments or questions and suggestions. It's just, it's a web app. And then in a couple of hours, they respond. You get an email that they responded, and you see all their comments. Sometimes they ask you to rewrite everything if you didn't do it right, or they suggest a faster way to do this, and you're like, cool, I can actually reduce the number of lines, by doing this. And then once they're happy with it, you go back and forth. Usually it's like 1, 2, 3, looks good. Or 1, 2, 3. You can go 50 times back and forth sometimes until you get looks good. LG, approval. If you get approval, you then submit it. Go ahead. Sorry. Áno, code repository system používame Perforce, ale máme na to aj Git wrapper, pre tých, čo majú radi Git commands, ale to ide do Perforce.
Že svoj kód komitneš do nejakého asi podrepozitária, do toho trackového, keďže robíš na nejaký feature. A ten, kto reviewuje, sa na tom tým pádom popúšťa. Nie, Perforce je trošku iný než Git. Ono to je pending. Perforce keeps, môžem po anglicky? Sorry. Ja neviem o týchto veciach, ja hovorím taký retard, keď hovorím po onom. So the change is, Perforce, the system knows what files you changed and how, because you have like your own client on your workstation that has those changes. And then when you just send the number
you get like a unique ID for your change. You send that to the person who is reviewing it. That person then, links on this thing that loads it from your machine, or if you keep it somewhere else, it loads it from there, and it shows it side by side. Only after you submit it, it goes into the repository for sure, like to the trunk.
Who chooses the reviewer?
Who picks the reviewer? Okay, so you should pick someone who knows about this code. And if you, tech leads, they do a lot of code reviews. I get a lot of code reviews. But I also send code reviews to people who are new, so they learn. Everyone should be code reviewing, but usually within the team. Sometimes when you're affecting code that touches other subsystems that don't belong to my team, but other team at Google, then I need to send it to them as well. So I might have like 3 reviewers, and they all have to approve it. Otherwise, I cannot check it in.
Do you create tasks for every code review?
We don't create tasks for code review because it's part of the task itself. We don't mark the task as done until it's code reviewed and submitted.
Yeah, but the task don't,
To do the code review? Or,
Yeah, if someone does the code review, it means that it's
They don't work.
another person involved in it.
Yeah, no, we don't. That's just part of our job. You have to do it.
Do you track the time to handle each task?
We don't track the time, but we know how big this task was. So theoretically, you can divide a week by the number of points we did, and you know how. But we don't want to think in terms of hours. It's all in terms of points.
If you are waiting for a code to be approved, what are you working on?
I'm working on pick another task. That's why people have multiple pictures on the whiteboard, so they have like 2, 3 tasks that they're working on. Yeah. And that's a problem, because sometimes code reviewers are too busy because they have all these code reviews waiting to do, and they also have to write a code. And so they just like, I'll do that tomorrow, and they just focus on the code, and then people are waiting, and That's one of the things that people can improve during retrospective, and they can decide, okay, every code review gets approved within 3 hours. It's a priority. Don't block your coworker.
There are always the same people in the team, or are you rotating?
Doing code reviews?
No, I mean the team members.
The team members? Yeah, I mean for maybe a year or people tend to, when projects change, right, like Google Buzz then somehow would be swallowed by Google Plus, and Google Plus is bigger, so people merge. But every team tends to live at least a couple of years. Some teams live for a long time, like Search. It's been around for a while, and it's not going to change for a while, hopefully.
Who can add the stuff to Icebox? Everyone or just?
Anyone can get the task to Icebox. Engineers, anyone. So when I'm working on something, it's like I don't remember anything. If you ask me what I was doing an hour ago, I probably won't remember. But you don't want to remember and write stuff on little papers all around you. If someone comes in and they ask for something, you're like, sure, I'll add it to Icebox, and then I forget about it. And then later I go through Icebox and throw it away or keep it, or decide what to do with it, with the PM.
And all the tasks that are chosen from the backlog, they should be done within the week, or?
So the question was, looking at the camera, the question was if all the tasks in the backlog should be done in the same iteration, the same week. They theoretically should be, but usually at the end of the week, there's still like 4 tasks that are pending, and then they'll be done. They'll just roll over to the next week. It just means that we're going to get fewer of them done next week. But we end up averaging pretty steady number of points per week, so it's all fine.
Do you have deadlines?
If you have deadlines, depending on what team, if you are a real customer-facing team that faces real people outside of Google, yes, you would have deadlines. If you are working on infrastructure at Google, you might have deadlines, or you create your own deadlines. It really depends. The more PMs you work with, the more deadlines you would have, probably. What's the question?
How do you evaluate developers' performance?
Okay. How do we evaluate performance? So if you want to know how much people get done, everyone works different speed. You can look at the number of points the person with the picture I mean, you look at who's working on what, and then you can add it up and see velocity of every engineer. But that's not what we do. We have bi-quarterly reviews, so twice a year we use another web app where it would say, this person needs to be reviewed. It would say like 5 people need to be reviewed, and you click on the first one, and you say, what do you think these people accomplished? What are their strengths? What things they need to improve on? You might even be able to suggest if they should be promoted or not. And this is the feedback that you keep getting. So you get feedback every 6 months from your coworkers. That's important. Manager then reads this, and manager would see, oh, everyone on the team is happy working with them. Okay, I'm going to support this promotion. And then they just go to promotion committee or wherever promotions happen.
Do you use test-driven development, or do you just...
TDD, yeah, test-driven development. So there are teams that do that, and there are teams that don't do that. So yeah, some people do that, some people don't. I've been on a team that does it. I've been on a team for a month. I was just trying out different teams before I switched to Gmail. And some people are preaching it, some people hate it. It really depends on the team. Yeah.
What project are you working on?
I'm working on a part of a Gmail front-end team. So front-end is the server side, not the backends, not the data, not the place that stores your email, but the servers that listen to the request that your browser sends. So you have JavaScript running in your browser, and it sends requests to the front-end servers. They're Java servers, if you're curious. Java. So Java is the front-end server. The back-end server is in C++, and it talks to many other servers. I mean, it's really busy. There's lots of other servers that it needs to load, like a chat server, contact server. If you're doing video chat, there will be a different server that gets involved. So there's lots of servers, and usually Java and C++ mixture. The front-end is Java. But the actual code that executes in your browser is JavaScript.
Yeah, but the JavaScript, are you writing it directly, or do you...
Libraries, yeah. But handwritten and using libraries. And then you have JavaScript compiler that compiles it, tries to shrink it to the smallest possible amount of lines and stuff like that. Okay, any more questions? Last question. Okay, 2 more questions.
How about the task assigned to developers? Developers use from task on planning meeting, or?
No, that's the beauty of it. The developer should pick the task that's on the top of the backlog. This is a very common question. What if you don't know how to work on it? What if it's something you don't know anything about, but your coworker does? Maybe she should be doing it. No. If she keeps doing that and you never do this, you'll never learn it. And if she goes on vacation, something goes wrong, then you're screwed. So the goal is, if you don't know it, you pick the task, and then you pair program with that person or ask for advice. It will take you longer, but eventually you'll learn about it. Last question. Sorry, you just had there's one more person that can get the last question. Okay, the guy. Huh?
Do you interact with the testers and the customers who bring up the task and request, for instance, clarifications and so on?
Okay.
Or if the task is not clear, you just mark it as unclear or ambiguous, and then it's up to the management to clarify.
So if we interact with customers or testers who might give us ambiguous requests?
Yes. So I mean, your job as a techie, as an engineer, is just to resolve the tasks which are down the pipeline. And don't call somebody like, what did you think of the task?
Well, obviously, I want to know what I'm doing really makes sense. If I don't understand, or if I think it doesn't make sense, I ask the PM, why do we need to do this? And they say, oh, because we did a user study and 20% of users really want it, or
I meant more when the case is not clear.
When it's not clear what they ask you to work on, you ask the PM to say, what do you mean? Is it going to be a button, or is it supposed to be, what is it supposed to be, the feature?
But you can resolve it yourself.
No, you can't guess. You want to make sure that, but the user story should be clear. So when the PM gives you the user story, or tech lead writes a user story, it's clear. And then during the meetings I was telling you, when people vote different numbers, it means the task isn't clear. And that's where whoever knows most about the task or explains what it's all about. All right, thank you so much for your attention. I know that you have a choice to be somewhere else right now, and I appreciate that you came here instead.